Hi everybody, very warm welcome to this webinar on Spark for fast batch processing. My name is Vishal and a very good morning to the guys who are attending from India. Good evening to the guys who are attending from US. Let us just get started, guys. So yeah, before I come to the objectives, just let me introduce briefly about myself. My name is Vishal, as I have told earlier also. I'm having around, I would say, 12 years plus of industry experience, and since last almost like 5 years or so, I'm working in this big data domain, likingly or unlikingly, but yes, this is how the journey started. And like for most of you, I'm assuming your journey also must have started like with the frameworks like Hadoop and something like that, right? So it was no different for me. Only thing is, when we started, Hadoop was just an experimental project. It was not even the top level Apache project at that point of time. Over the period of time, moved on to the other projects also, like Storm. Then there is something called Spark, on which we are going to talk right now, and various others. But if you say right now, my specialty lies into the area wherein we have to integrate these new big data systems. Okay, we used to call them as disruptive technologies, basically, to integrate them with the enterprise system. So that's where that's where I'm working currently. Domain wise, it is primarily into the retail domain and the banking domain. There were a few healthcare or telecom sector projects as well, but again, they are like quite negligible as compared to the overall experience. And I think, yes, that's it. We should be keeping it that short about the introduction thing. We'll discover more as in when we meet, in hopefully in any of the coming classes altogether. Now, coming to the objectives, which we plan to cover. It's a bit ambitious, list, but yes, at least to give you the idea about. Not sure how many of you are, just attending this webinar without really having worked already in the big data domain, right? So at least those people who are just starting their career in big data domain altogether, just we'll take a very quick step in understanding, the domain. Spark, be it Hadoop, be it Storm, all of them are the frameworks which are going to solve some specific problem for you, right, in the big data domain. So first of all, just try to understand what exactly big data domain is, and why is it kind of such a buzzword nowadays, right? The fact that there are so many people attending this webinar itself is a proof that yes, there is some traction altogether, right? So what are the challenges, which make this particular field as one of the most talked about ones, right? So we'll try to take a very quick look of it. Then we'll go directly to the crux of the matter. It's about, what exactly is Spark and how exactly it is going to help you in some of those challenges, in tackling some of those challenges, right? Spark is a bit different from the other big data platforms, I would say, because it's not a specialized system, it's a framework. What do you really mean by a framework? And what is the framework of Spark, if any, right? So we will try to have a look of that when I'll talk about the Spark, this thing. Just a second. Guys, I hope you are able to see my screen, right? I hope you are all able to see my screen. I'm on slide number 2, which talks about, great. Okay. Sorry, so Mahendra is not able to see my screen. Mahendra, I hope you are able to hear me. Probably this might be due to some internet connectivity problem. What you can try is just try to log out, log in back. You should be able to see that. Okay, because there are other people who have already confirmed. specifically right now Mahindra and Sushmita. Guys, if you just log out and try to log in again, you should be able to see that. Okay, great. So just continuing in the meantime with it. So what exactly is the Spark ecosystem? That is something which we'll quickly talk about. And then I'm sure if you have heard about big data, then you must have heard about Hadoop also, right? And of course, any player or any framework in the big data system, definitely there is a requirement to integrate it with Hadoop, right? So we will just see that what really it means. Of course, this is at the same time you will get the idea what exactly we are going to cover also, right, in the course also. So this is something which is important. And then a very quick look about Spark in industry. I would say that's a very you know, we'll have a very quick look about it. But then RDDs, there is something called resilient distributed datasets. So just to give you a one-liner that everything you do in Spark is an RDD. Okay, so what is the RDD? What is resilient distributed dataset? It will just be introduced to you today, because you know, of course, there are like there is already 1.5 dedicated. There are 1.5 dedicated modules about it in the actual course about it there. And as it happens, none of our presentations, none of our classes are done without the hands-on part. Here as well, at the end of it, we will take a simple problem. We will, I mean, a very known program. Okay. Only thing is, I'll just show you on the very same data, on the very same machine, with the very same processors. I'm going to run Spark. I'm going to run MapReduce, and then we'll just run that, and we should be able to quickly see their performances. Make sense? The comparison looks good to you guys? Looks like a worthy amount of topics for 1 hour of your investment, right? Okay, I hope all of us are good to go, and let us just get started quickly. All right, thanks a lot, Sunil, Samir, for confirming. Okay, with that, so guys, the first thing first, you know, what is big data, by the way? I'm sure many people have heard about many you know, definitions and all that stuff. Let me just start from the eyes of a developer, right? The simple definition is, the definition of big data is you have huge amount of data or lots of data. Well, what do you mean by lots of data? I would say, if you were, let's say, working some 5 years back or something, and your database administrators and all, if they used to see that your database file size is several GBs, you know, 10 GBs, 15 GBs, etc., then they used to say that, you know, you are dealing with a large database instance, or in other words, big data instance altogether. So this was the scale some 5 or 10 years back. Right now, if you talk about the scale, it has just moved. It has just moved to, you know, late GBs to the early terabytes. When I say late GBs, it's like 600-700 GB data, or whatever, 2 terabytes, 10 terabytes of data, etc. Right? So this is what you mean by the you know, late GBs and all. Probably some years down the line, when people will be talking, then it might be mid terabytes or late terabytes to the early petabytes and all. Again, this kind of scale which I'm showing, or the kind of scale which I'm talking about, is a more generalized rule. The kind of normal companies where people work, if you talk about the companies like LinkedIn, Facebook, Google, etc., they are already at the scale of, you know, several petabytes or zettabytes, not even at, probably Google at zettabyte and something, but yes, several petabyte kind of a scale, right? So the moral of the story is, this entire, you know, volume part, right? The volume part of this data is a continuously moving target, right? It was early GBs to late GBs to early terabytes to late petabytes, all that stuff, right? Okay, fine. So I hope this is a very rudimentary or rather oversimplistic explanation altogether, right? What exactly are the challenges, which come along with it? You're talking about huge volume of the data, that is fine. But what are the challenges which come along with it? So guys, let me just start with a very basic example. This is my pet example. I always keep telling you. Keep telling people also about it. So guys, you're all, I'm hoping most of you are attending this webinar from your laptops, right? I'm assuming, so let's say if I ask you the question, what is the hard disk capacity of your laptops? Your answer would be 250 GB, 500 GB, 1 terabyte, probably if these are the latest ones, right? Or probably 2 terabytes and all. Am I right? Not more than that. Now, the point is, the moment I say, okay, this is your capacity of your laptop. If I give you some 20 terabytes of data, can you process it on the same laptop? The answer would be simply no. Why? Because you do not have that much capacity. Fine. So how are you going to store the data? You are definitely going to store the data into multiple laptops or multiple systems, multiple disk drives. Am I right? The moment you talk about it, you are going in the direction of distributed storages, right? You are no more talking about the central storage of the data. You are talking about the distributed storage of the data. What does that mean? If you have the file system today, whatever file system you are using or whatever operating system you are using, whether it is Windows or Linux or MacBook or whatever it is, right? If you have to fetch a file, you just give the name of the file with the entire path, and then that file appears in front of you. Why? Because your operating system as well as your file system, they know how to fetch that particular file. But what if your data right now is available on multiple machines? The kind of operating system or the file system which you require has changed. The kind of file system which you require has changed, because now your file system need to look at multiple sources of the data, and then it has to fetch the right kind of a file. So the abstraction layer is completely different. Guys, are you there with me? Right? I hope you are getting the first point of it, right? That the moment you have said that my data is such a huge one, you are going in a completely different direction of the distributed storage and then simply the distributed fetching of the data. Okay, fine. Again, believe me, I'm only at the 10,000 feet level. I'm not going into the details right now. Then the second point comes. Why are you, by the way, going to store such huge amount of data? Why are you going to store such huge amount of data? Because you would like to process this data, right? You would like to do some sort of processing for this data, either some sort of analytics or do some sort of crunching out of it, or for the simplest matter, you just want to go through this data, just have a single pass of the data, right? Do some data profiling and all. If you want to do this, if your storage cannot be central, can your processing be central? Your processing also cannot be central at all, because now your data is distributed. So your processing has to run across multiple machines. Now you are again talking about a different world, right? In the conventional way, how do you write your programs? You write a program, you supply the data to it, and then you generate the output. Am I right? Now, in this distributed world, the approach is not going to hold true, because your program now has to run on across different machines, right? And now the way you are going to monitor your program, various scenarios, right? Let's say your program is running on 5 machines, and your program succeeded on 4 machines. The 5th machine has failed. How do you want to tackle it? Do you want to run the entire process again? Are you okay with one failure? Or are you not okay with one failure, right? I mean, whatever would be the answer, they will depend on the situations, right? But these are all the different scenarios. And then you would definitely need the abstraction layers which will manage, or the decision system which will be taking care of these aspects, right? So now even if your program is as simple as read the data, filter it out, even in this very simple sort of a scenario, the way you are going to execute your program is completely different. Are you guys getting my point? Right? So this is just one part of it. Now, the challenge keeps on going across the, so if you talk about these challenges, so be it the capturing of the data, be it the storage of the data, be it sharing of the data, transfer, analysis, or even for that matter, visualization part of it, right? Everything just changes upside down from the traditional world altogether. Then these are just the challenges which I have told you from the perspective of you as a developer. Okay. There are other challenges also, right? So first thing, we just talked about volume. It's nothing new. Then the second thing, have you heard about, I'm sure most of you have heard about the New York Stock Exchange example, even the Facebook example, right? That New York Stock Exchange generates 1 terabyte of new trade data every day. 1 terabyte of new trade data. Is it volume something new? No. What I'm talking about is in a day, right? So, and also it has to be processed before the trade begins next day, because you have to find out the optimal trade rates and all of that stuff, right? So the second aspect is not just the volume part. The second aspect is the velocity part, the rate at which you are gathering, or probably possible, then processing also, right? The rate at which you are gathering or processing the data, that is called the velocity part of it. Then there is another aspect of it. Let me just move to the next slide. Okay, so I'll define this slide a bit later, but I'm just right now, this is a definition. Either I could have started from the definition. My approach right now is a bit different. I am taking them one by one, evolving, and then I will come to the definition, right? Then the third part, guys, you look at your Facebook account. I'm sure almost all of you would be having Facebook accounts, right? So what do? There are people who update their status, right? They upload the photos. Some of them upload the videos also, right? So all of this, if you talk about it, the Facebook update you did, I'm feeling happy, I'm doing this or whatever, I've been to this place or something. This is a textual data, right? Your images are that's the image data altogether, or probably some video files or something, right? You talk about it, you are having different kind of data which you are kind of, uploading. It might be structured, it might be semi-structured. Well, in Facebook case, there is nothing called structured at all, right? You are just uploading all of the unstructured data. Or if you are a bit lucky, probably you might be having some sort of web logs or server logs which are semi-structured, because typically when you are logging them from the applications, there is some sort of structure which you can impose, if not all, right? So this is the other case wherein you are not having the data from different tables. You are having the data from different sources which can have different structures altogether. And we call that kind of complexity as the variety complexity altogether, right? Then comes the fourth thing. Again, the fourth thing is that veracity is something which is not the part of official definition, but yes, it is one important aspect. It's all about the anomalies of the data, right? You have a huge amount of data and then some of the observations are missing, right? So all of you, I'm assuming that basic programming experience in the SQL or in Java world or any other programming language, right, would be telling you most of the languages treat any operation with null as null. Am I right? Right? Any operation with null is null. So if you are just trying to find out the average of, let's say, 100 million entries altogether, and only 2 of the entries are null, for that matter, the observation missing, so system typically treats it as null, right? So what will happen? Your average will be just null altogether. Now this is what we mean by the veracity part of it. You have to curate your data. You have to do some sort of pre-processing of your data so that you remove the anomalies and all, and these anomalies might be completely unknown to you when you got the data. right? So you will discover them one by one when you will start processing the data, right? Guys, I hope everybody is quite clear by now. This was my very quick shot about the definition of big data and the kind of challenges which come along with it, right? And if you try to combine all of them, this becomes the official definition of big data, again given by IBM. The URL is also presented in the very same slide. It's all about volume, velocity, variety, and veracity part. Right, guys? Are we quite good to go? Right? Should be quite straightforward. And I'm just moving to the next slide. Great. Now, guys, if this was the definition of big data and the associated challenges, we just took a very quick stab on it. Let us come to the point wherein we'll say, you know, what exactly is Spark? Because this is what the webinar is all about, right? So Spark is a framework. Okay, sometimes I ask this question to the people whom I interview. I get some nice answers many times. People say it's a database. There are some people who say it's a tool. No, it is a framework. Okay, now let me just give you a quick official definition and then let me dissect it, right? So Apache Spark is actually a data processing framework, okay, and it allows you to do the distributed data processing across the cluster of, you know, different machines altogether. And the kind of processings which you can do might be a batch processing, it might be a streaming processing, or you might like to do some sort of interactive analytics. Not sure how many of you have seen the data scientists working. They typically like the systems wherein they should be able to interact. You know, they should not be writing a program, compiling it, submitting it, and waiting for the result. They want immediately fire a command, just like your SQL prompt, right? Just like your pig prompt altogether or hive prompt. Just write a quick command and get a quick result out of it, right? So you can do all of those kind of analytics altogether. This is a framework which was developed in UC, you know, Berkeley altogether. This framework is completely written into Scala. Scala is a functional programming language, and you know, it runs in a JVM. Sorry, it is a spelling mistake here, typo. It says JMV, but it is a JVM. And the third point, I would say, let's park it for now. But yes, it aims to generalize the MapReduce framework. So those guys who are aware of Hadoop or who have heard about Hadoop and MapReduce, MapReduce is a paradigm altogether to solve a problem. It has got its limitations. We will see them very quickly in one of the upcoming slides. Okay, but yes, the idea is those limitations, it aims to remove those limitations and generalize that kind of framework so that the other kind of problems which are not easily supported by MapReduce could also be solved. Now, point is, I just told you that Spark is a framework, right? So please just hold this point with you, because I will explain, or rather than holding, let me just do half of the discussion right now and half of the discussion when I come to explain you the framework, right? So guys, a quick question to all of you, right? What do you understand from a framework? What is a framework, by the way? Just one-liners will do. You don't have to type big explanations. One-liner. What is a framework in one line for you? So, right? Correct. Okay, fine. Please, some more answers would really help. There are almost like, there are so many people already in the class. I mean, in this session. Great. So guys, a framework is something, exactly. Framework is something which really helps you to do the things altogether. It's a collection of various utilities altogether. What might be some of the examples of framework? The examples of framework might be like struts, like you have Ruby on Rails, right? And then there are various others. Let me take the example of Ruby on Rails. So what does it do? It provides you all of the utilities to do the web development all together, right? You just follow the scaffolding part, and then all of your model layer, view layer, controller layer, all of that gets created automatically. Your migration scripts get created automatically, which create the database tables or indexes or whatsoever for you, primary keys, definition, etc., etc., etc. All of that thing is done by the framework itself. So what it does, it says, or the overall idea of any framework is, you focus on application development, you focus on the business logic, and all of the peripheral things are taken care by the framework, right? That's how you define any framework. That's the objective of any framework, right? And Spark is no different. Spark, on the other hand, as I said, that whatever batch analytics you want to do, streaming analytics you want to do, interactive analytics you want to do, it will provide the tools for each and everything. Or let's say you want to do some sort of data ingestion. So it should provide you some sort of integration with the systems so that you can do all of these activities. And hence we call Apache Spark as a framework, just like Hadoop is a framework, right? But you never call Apache Storm as a framework, by the way. Storm is a system, right? Cassandra is a system. It's a tool altogether, right? Spark is a framework, on the other hand, which will provide you multiple capabilities, right? Guys, I hope it just gives you some idea, right? Now, what are the components of those framework and other stuff? I will come to them very quickly, right? Now, this was about what is Spark, right? Now, a few things which actually are in favor of Spark. So guys, first thing first, the USP of Spark is its speed, right? You will realize it right today itself. When I will do a quick comparison of both of them on my machine. It's not like, you know, I'm comparing apples with oranges. When I'll compare apples with apples, you will see the speed, right? In some of the cases, specifically, Spark programs run 100 times faster, almost 100 times faster on the very same input, on the very same framework, very same infrastructure, on you know, almost 100 times faster, right? So this is, of course, who would not like to have that kind of speed on the very same infrastructure, right? That is the first thing itself. Of course, some of you might be thinking, okay, how does it do magically all that? No, it's all about in-memory processing versus the, you know, the processing wherein you fetch the data from you know, from the hard disk. So we will talk about that in the actual classes altogether. But right now, the idea was to give you some indication, right? It is quite easy to use. When I say quite easy to use, there are people, you know, no framework can be successful if it is bound to a specific language, right? So Spark is written in Scala, and hence we also will be covering the Spark coverage in Scala. Okay, now that you might be having some question that it means, do I need to know Scala already and things like that? Please hold on till the end of this session. I'll tell you about details about that also. But yes, it supports Scala language, it supports Java language, it supports Python language, right? You can write your Spark programs in any of these languages. However, we at Edureka strongly suggest you to use Scala. If you are a professional Java programmer, then and you are determined to use Java, our suggestion would please use Java 8. Don't use Java 7 or any below version. The reason being, you will explore when you will understand Java 8, because it provides you the support for function programming and other aspect, right? In fact, we will be launching a course on Java 8 very soon on that part also. The next thing is, it provides you the generality. So this would be the first place wherein you should be getting some idea about the framework altogether. Apache Spark, these are the different you know, packages. So somebody wants to do some sort of SQL kind of a processing, or you want to do some sort of machine learning, you want to do some sort of graph processing, etc. There are various you know, wrapper packages which are built on the top of core Spark engine. And then you can do various kind of domain specific processing altogether, right? So it's quite general also. And then the best thing, Spark has got excellent integration with the other big data ecosystems or the components altogether. So you want to run Spark standalone, you can do it. You want to run it with Yarn, you can do it. You want to integrate with Hive, HBase, Mesos, Cassandra, it's so easy. Okay, in fact, in the course we will be covering Spark standalone, then Spark with Yarn, then Spark with Hive. Yes, we will be covering that. We will not be covering Mesos. Okay, now this was about, so this was all about when we said that what exactly goes in favor of Spark. Just continuing the very same discussion, so MapReduce was a very powerful paradigm altogether, and it is still for the batch processing. However, it is suitable for some sort of calculations, and it is not suitable for some other kind of calculations altogether. It is most suitable for the calculations which can be done in one pass of the data. Go through the data and do whatever you want. You can do that. But wherever you have recursive kind of, not recursive, wherever you have iterative kind of, processing, MapReduce is not the best idea. Because for the iterative processing, you might have to go through the data many times. Hadoop is not the best place. Hadoop is not the best place to do those things, right? The next thing, if you want to chain multiple MapReduce jobs, right, you have to store the data, or you have to process the data of the previous jobs into the hard disk altogether. Again, it's not a very good idea altogether. That chaining, if I'm persisting it, then there is always a cost of persisting, reading. If that can be avoided, it will improve the performance quite a lot. And Spark has actually leveraged all of these pain points, and it has tried to remove all of them, right? So these are some of the things, right? And again, MapReduce jobs are a high latency jobs. Even the fastest MapReduce job is going to take few seconds to run. So if you are expecting the response in kind of, fractions of seconds, probably, MapReduce is not the best way. You have to go for some faster batch analytics kind of a system like Spark. So these are some of the ideas wherein I was just trying to tell you about the limitations of MapReduce. And here I give you the second part of the idea wherein I say Spark is a framework, right? So these are some of the things which I'll tell about Spark ecosystem. But in between, seems like there were several questions which were parked in between. I'm just trying to, guys, please forgive me if I'm not able to answer all of your questions, because there are so many people and there is only 1 hour with us, right? So let me just see if I can answer few of them, right? There are people who say that for graph analytics, do we have to use some tools, or Spark itself provides that facility? So Mayank, this was a question from Mayank, I think. Mayank, you will get the answer right now in this slide. Okay, and please confirm once I'm done with the slide. If you didn't get the answer, then I'll explain it once more. Okay, now so guys, this is the ecosystem of Spark altogether. Now what is the in it? It's like you have this core Spark engine. It's like your raw programs of Spark. You can write them, and they basically are they directly hit Spark core engine. Then you might be coming from the background of SQL altogether, right? The people who come from the background of SQL, there is a project called Shark. By the way, Shark is closed now. It is called as Spark SQL. Okay, so you can actually read it as like Shark/Spark SQL. This is something which allows you to do some sort of SQL-ish sort of a processing on data. It's almost equivalent to Hive for the people who are coming from the Hadoop world. Only thing is, it's almost 100 times faster. That is the biggest idea. Then there are some of the cases wherein you are getting the streaming kind of a data, right? The data which is continuously being streamed. Uh, so you know, the application like a Storm type of application wherein you are continuously getting the stream kind of a data, you will be talking about the Spark streaming. So Spark streaming is another wrapper which allows you to do the processing of such kind of data. You want to do some sort of machine learning. There is, so like in Hadoop world, you have something called Mahout. However, the latest release of Mahout will come with the support of Spark. That's a thing on which, you know, still the work is going on. But yes, Spark has got its own library called MLlib, which basically supports these kind of machine learning algorithms. Then graphics and Spark R. So graphics is about, you know, your graph processing of the data, and Spark R is about, you know, R is a statistical language. So if you want to do some sort of statistical kind of processing, you will be supporting it using Spark R, right? Then there is an interesting package called BlinkDB. It is approximate SQL. So guys, it's like it tries to trade off between the speed and the accuracy. So many times you are not interested in the actual results, right? When I say actual results, it's like what is the best example? We had IPL some months back, right? So in IPL, there were continuous tweets altogether. You were not really interested that there are 30 lakh, some thousand, some hundred, you know, number of tweets. Probably at any point of time you were interested. Right now I'm having 350,000 plus tweets. Now I'm having 450,000 plus tweets. You're not really interested in the exact number, right? So if you want to do those kind of calculations, BlinkDB is the package which actually talks about it. Now, a bit about color coding. By the way, there is a small mistake in this slide. This this MLlib also should be in the orange color. So all of the packages which you are seeing in the in the orange color, they are basically the alpha or pre-alpha releases. They are not yet available for the active uses by the programmers. Spark R has become just 5 days back. We have released Spark R, but it is still unstable. So like, you know, people are, so Spark 1.4 has released Spark R, but there are very limited operations. They are still in the process of extending it, right? So whatever are you seeing in the blue color, right? Spark streaming, Shark, Spark SQL, and the Spark core engine, they are the ones which will be covered in the course also, because the other APIs are not yet open for the active development. But yes, so to answer the previous question which was asked, graphics would be just an API. You would not require anything. You just need to import those specific classes to do the graph processing on Spark. Is that clear? Sorry, I just forgot who asked this question to me. Right, Mayank, I hope you got the answer. Great. Now, with that, just quickly moving towards some of the features of Spark, right? So again, I would be quite quick into this. It's all about, you know, as you know, that Spark is gonna do the generalization of MapReduce altogether. There are few things which actually make Spark really powerful. So one thing is, of course, the generalization of your MapReduce framework, as I have told you already. The next thing is Spark follows the principle of in-memory computing and lazy processing. Okay, so lazy processing, does it remind you something like, especially those people who are from Hadoop world, you know, you must have heard about PIG, the directed acyclic graph, lazy processing, and all that stuff, right? So typically that happens for Spark also. You know, it just keeps. So I told you everything will be an RDD, resilient distributed data set in Spark world. So Spark keeps the lazy processing on for them, and until and unless you are going to perform some certain actions on those RDDs, Spark does not really execute the programs. And then whenever it executes the programs, those typically happen in the distributed way in the memory itself, or it can be on the disk also, or it can be the combination of both. So 70% of data in memory, 30% data in disk, or vice versa, whatever you want, right? So all of those combinations are possible. That gives Spark immense power, point one, immense flexibility, because many times you might not be having that infrastructure which is going to support all of the data in memory, right? So you might want to take a mid path altogether, right? So Spark gives you that flexibility, that room of flexibility. You are not able to get that in Hadoop, right? Of course, Hadoop has a different use case. I'm not trying to compare both of them for the same use case, but yes, wherever there is a boundary, Spark is a clear winner on those things, right? Now, and of course, by now you must know that you can do the development in multiple languages. Right now 3 languages: Scala, Java, and Python. 6 days back, as I told you, they have introduced R also, but just I would say be cautious, wait for some more time, let it to mature, and then you can start exploring it also, right? And then of course interactive analysis. So Hadoop is very popular in the developers, but it is not very popular in the data scientists. The reason being, they are not able to do the interactive analytics. Spark, on the other hand, allows you to do the same, right? So that is another reason altogether for its, so these are some of the USPs of Spark. Then on the same USPs, right, I would say Spark provides you the excellent integration with the existing systems, right? I've already talked about it, but yes, here I'm just trying to show you it in graphical fashion, right? So if this is a Spark ecosystem, the upper part, BlinkDB, Spark SQL, blah blah blah, all that up to Spark Core, all of that is a Spark ecosystem. But then the 2 layers below it, it is like cluster management or the storage part of it. This can be anything. Spark is just a processing framework, right? But what will you do of processing if you do not have the data, right? So in that case, you want to integrate it with any kind of distributed storage like HDFS, like Cassandra, like HBase, etc., etc. It easily supports the integration. You want to have the cluster management, either its own cluster management, or there is other industrial cluster managers like Yarn, Mesos. Right now these are the only 3 one with which the this Spark integrates. But yes, if you want to do that, it's damn easy. It's not like there are 100 configuration files, then these are 200 settings which you have to change. No, it is not that. There are few basic things. Just copy paste your exact configuration files from Hadoop to a specific folder in Spark. You are up and running. Restart, you're done. So it's that easy, right? So these are some of the things which of course make Spark as a compelling thing altogether. The reason due to which many people are even moving to Spark nowadays, right? Now, so this is where I was just comparing the same things. It invokes another thought in people, wherein people say that so does it mean that Spark is going to replace Hadoop? Does it mean that we will have only the Spark applications in future and no Hadoop application? Of course, guys, this is not true, because I told you the areas which typically these two frameworks, right? These two frameworks deal with, right? They are completely different ones, right? So now I will give you an idea how exactly typically people use Spark in industry. Either they use it standalone, or the most popular combination, which is famous in industry, and it is many times people call it as the Lambda architecture implementation. I would say it is one of the implementations of Lambda architecture, is Spark plus Hadoop. So now in the coming few slides, I'm going to talk about what exactly do you gain when you talk about Spark and Hadoop integration. But before that, I think I can take one or few more questions. Okay, this is another recurring question wherein people are asking about what is the DAG. It's a directed acyclic graph. Guys, So typically, again, I'm not going into the full detail of it. So this is just a full form. In the context of Spark, what really happens is, whatever operations you define, Spark keeps the graph of those operations with it, right? That you loaded the file, you filtered the file, you transformed the second field to uppercase. Let's say if this is the operation you wanted to do. Now Spark keeps the graph of these operations with it, and then whenever you want to actually fetch the data, you will perform some action. Okay, in Spark's world, you will perform some action, then and only then Spark is gonna execute these operations. Is that clear? I think Kamesh asked this question, and then I think few more other people asked this question, right? Kamesh, others? I hope you got the idea about it. Great. Thank you. I mean, this is just a very high level idea, but I would encourage just try directed acyclic graphs. You'll get more idea about it. And again, whatever I explained, it is in the context of Spark. Now, coming to some of the advantages of Spark. So by now you have seen already, right? I'm going to do a very quick thing. Sunil, I'll just answer your question in a bit while. Let me just complete this part. Sure. So some of the advantages which you can clearly imagine right now is, of course, you are having easier APIs. You can do the development in multiple languages. In-memory performance, I told you everything, whatever you will do in Spark is going to be the RDDs. Then the other thing is you are going to have multiple packages, right? You want to do some sort of, you want to do some sort of SQL kind of operations, machine learning and all. You are having different wrappers altogether. These are the advantages of Spark, right? Now, if you look at the advantages of Hadoop, right? Well, I'm not going into the details right now, but they are well known, right? Unlimited scale. You want to, it basically talks about the horizontal scalability part. It is almost kind of an enterprise platform now, like as compared to a few years back, right? Multi-tenancy, security, reliability, all of those features are now well developed, well matured now, right? The next thing, which is more important, is it basically supports wide range of applications altogether, right? You want to fetch the data from the files, you want to fetch the data from the databases, you want to fetch the, say, structured data, semi-structured data, unstructured data. It supports all, right? So this is the area which is the stronghold of Hadoop, right? What really, literally, when you marry Spark with Hadoop, right? This is exactly what you get. Right, you get the ease of development at the unlimited scale. You get the enterprise platform which supports your in-memory processing altogether, and then on the wide range of applications altogether, you are able to combine the workflows. That is where this is what makes it as a sweet spot. This is what makes it as one of the hottest places wherein you can actually integrate Spark and Hadoop, and this is how you typically get the I would say best of both of the worlds. In the actual course, we are going to cover this integration also. So when you talk about, basically there are two ways in which you can integrate Hadoop with Spark. We will be talking about both of them in the actual course, right? I think there should not be any need to talk about this slide in a lot of detail. The fact that there are so many people attending this webinar is the example. You guys must be representing your companies, right? You can add your company's logos in it, right? There must be a reason, right? Either you are having a center of excellence which is starting the work in it, or you might be getting some sort of client project altogether. So there are like so many companies. By every passing day, there are so many other contributors also. But yes, these companies are the contributors also. They are not just the users, right? So this is one. Before I proceed forward, now I'll just try to take a few questions from people also, wherein people said that when you do Spark operations or RDDs in memory, what happens when the underlying data changes in, say, SDFS? If we have integrated Spark with SDFS, please ignore if my question doesn't make any sense. No, guys, it makes quite a lot of sense. Just that it is a very logical question. Only thing is, what will happen will completely depend on you. When I say you, if you have cached the data, right? If you have cached the data and you have not done a provisioning of data change, if you don't envisage the data change, then you will keep on referring to the stale copy. But if you have not cached the data, then every time you are going to fetch the latest data. Okay, clear? But let's say you have cached the data and you identify that yes, the data can change. You can unpersist it, uncache it, and then rerun the query. Then you will always get the latest results. So it will just completely depend upon how exactly you have programmed your system. But yes, all of the possibilities are available. If you cache it, till the time you are not going to uncache, you will be referring that, you know, cache data always. Got it, Kamesh and others? Right. One more question people have asked: can we analyze JSON data using Spark as Hive does not support? Yes, Sunil. In fact, this is something which we will definitely show in the course also. We show them how to integrate Spark SQL with JSON, with the you know, with Parquet file format. In fact, all of the file formats which Hive also supports. So we will be showing all that. Right, Sunil? I hope you got the answer of your question now. Okay, guys, I realize that we will be taking 5 minutes more. You know, let's say up to 8:05. I think it should be okay with all of you, right? Basically, I want to show you the hands-on part also, right? Sure. Thanks a lot for confirming, guys. Thanks a lot. Okay. Now I will just go with the resilient distributed data set. Again, it's a very quick look. I'm not going in any of the details right now. It's all about, guys, RDDs. Just want to mention very quickly that they are the fundamental units of the data. Okay, they're the fundamental units of the data in Spark. Everything, whatever you are going to do in Spark is going to be in RDD or the operation on RDD. The full form of them is resilient distributed data set. They are resilient because if you're talking about memory, right, RAM, what if your system goes down, right? So they are resilient because even if the system goes down, when it comes up, they can be recreated. How? We will talk about it when, you know, in the actual course. They are distributed, so you're not talking about the RAM in a single system. Your data, we already talked about it, right? That your data can be distributed across systems. Then your memory is also distributed, but yes, the state is shared, right? That's the best part of it. And Spark gives it for free to you. You don't have to do anything on your side. And dataset, I hope this is the least important part, or rather than least, this is the very easily understandable part. It's a dataset, right? Whatever the data you are going to maintain in the memory, right? So it's a core part of it. It supports all the primitive types. You know, you can load the data from the textual files, the sequence files. You can load the data even from the console also, right? So all of them. And the important thing is RDDs are immutable. By the way, this is just a statement right now. You will realize the importance of this statement when we will talk about Scala and other stuff. So all of this strength are drawn from Scala, wherein Scala goes for immutable data structures. They are basically thread safe all the way, right? And RDDs are always going to be immutable RDDs for you, right? Typically, there are two kinds of operations, where one are the transformations and the other are the actions. So guys, typically the transformations are when I say transformation, it's like, let's say you want to convert a field into the uppercase or to the lowercase, or do some sort of, you know, concatenation or something. All of these are the transformation of the data. Typically, whenever you do any kind of transformation, this does not result in any processing. They just create another RDD, and this is what we mean by the lazy thing. You know, Spark is lazy. Spark will just note that you did some transformation, but then there are some certain kind of actions. Okay, when you say action, you might want to collect the result. You might want to count the number of records. You want to take the first record. You want to, you know, for each record, you want to, let's say, just print the record. All of these are the actions. only and only, you will see them in detail in the course, but yes, only and only when you enforce an action, Spark comes into picture, or Spark processing comes into picture. Till that time, Spark is lazy. It's just gonna, keep recording the actions, keep it in memory, and will sit silent, right? So this is just giving you some idea. I'm just giving you some ideas that, at least you should. I mean, if I'm giving you a statement that yes, Spark is fault tolerant, if I'm giving you the idea that Spark can recover the data, I'm giving you the data points also right now, right, which support these things. Okay, and now I'm at the last part of or I would say the second last part of this entire uh, webinar, which talks about the Spark versus MapReduce performance. So guys, let me tell you my intention. Pretty simple. All of you have heard about word count. Word count, everybody has heard about it. I'm not going to tell you what is the word count program. I'm going to run the very same program, MapReduce, and then in Spark. The same data, same machine. Let's see the performance, and that should give you the good indicator what exactly comes up. Looks like a fair idea, right? Looks like a fair idea to all of you. Are you excited to see that in the system? Right? Just as a supporting, fact altogether. Right, guys? Okay. Before I proceed to it, right, because I know after that you guys have to continue for your work also. Just a quick thing to all of you. The way we have decided, the way we have distributed this entire course is it's not a marketing kind of a webinar. Idea was to give you some knowledge altogether about these topics. So if these things will excite you, then and you want to join the course, we just want to tell you very quickly the way we are planning to organize, or the way we have organized the course right now. It's all about, we have 8 modules of course. We realize that there are people who are new to Scala, right? However, it's like, Hadoop is done best in Java because it is written in Java. The same is true with Spark because it is written in Scala. Hence, you will do it best when you do it with Scala. You might not know it. So the first 4 modules basically talk about Scala and the essentials of it. This is again not going to focus on what is for loop, what is for each loop. No, we will assume that you know these constructs. Only thing is, syntactical wise, possibilities wise, how are they different from the other programming languages, let's say Java, right? How exactly they are different. So those are the things, and they will equip you enough to work on the remaining 4 modules, module 5 to module 8. Basically, we talk about introduction of big data and Spark. Module 5 is going to be a bit theoretical and a bit of practical. Then from module 6 to 8, it's all about that practical, wherein Spark baby steps, playing with the RDDs, Spark SQL. The things which are not mentioned here are like Spark streaming, right? Spark streaming would be there in module 7, and pair RDDs and all that stuff, right? And dealing with the sequence files, creating your custom partitioners, all of those things, right? So all of these things, this is how we have broadly defined our course. Course features and all, I would not go much into the detail because I'm assuming that you already know the way Edureka works. If you still have the question on those sides, right, guys, do ask me. Now I'm moving on to my that presentation, right? So this is all I had to say from the presentation perspective. Now let me just go to the screen. So hold on, guys. This is my virtual machine. We will be telling you how to set up your virtual machine when you will join the course. Right now, let me just tell you the setup wise what exactly I'm trying to achieve here. Okay. So simple thing first. I'm having some of the data available in HDFS. Okay. So let me just tell you where exactly my data is, and then let me just start from there itself. Okay. Hold on, guys. Hold on. I'll say Hadoop fs-ls Okay. Now I will say these are my directories, inputs. In the inputs, I have Spark input. That's my folder. You can see there is a file called hello app input1. Okay. So just a second. Now, what I'm going to do is I'm just going to give you some idea about it. What are the number of records which are there? You can clearly see that it took some time. There are like 188,000 plus records, right? 188,416 records are there, right? 1,88,416 records are already available in this. So it's a sizable input, right? You want to see what exactly might be there. So there are just few words which I have copy pasted, right? Vijay, Raj, Delhi, A, something, right? Basically, it's a word count altogether. Or let me just, even do a bit more for you. So you can see that, right? Now, what I'm going to do is, I'm going to run a word count, which will give you the word frequencies. And then I'm going to run the same, on the very same input, I'm going to run the Spark program, which will produce the same output only in much lesser time, right? So now, in order to do this, let me just say yarn jar altogether. Oh, sorry, I took a different, hold on guys. It is my names.txt. Sorry. The kind of file, that's what I was just thinking while telling you, right? That my file looks a bit different today to me. Sorry. So these are some of the names: Vijay, Sumit, Jay, Vijay, etc., etc. And the number of records also, if you look at the number of records, they're going to be quite huge. Oh, quite less right now. No problems with this. Now, what I'm going to do is I'm going to run this program, yarn jar. Basically, this is a word count program which I'm running on the names text, and I'm producing my output in mr_op. So I've just fired it. You can see the, right? This is the word count. It is still running. Right? And then if you do this, can you see the time? Elapsed time is 16 seconds, right? And if you really want to see the output, it is hadoop fs-cat mr_op head, right? So effectively there were only this many number of words which were there, right? Now I'm going to, so guys, you saw that, right? The output. Now let me just fire my Spark shell. Okay, so now I'm firing my Spark shell. Fine. All I will do is I will say that load. Again, please do not focus right now on the just a second guys, what happened? I think I just need to say, okay, /home/cloudera. Let me at the same time, just for you, what I'm going to do is I'm going to increase my data size to manifold. See this, name.text. And if you see, my original record had only 1056 records, right now, and this is also 1056. Okay, it's the same thing. 1056 records are here as well, right? It's the same file which I'm doing. See this, 1056 records. I will just say load it. Okay, please for some time, please just I hope, just a second. Understanding the syntax should not be that difficult right now, but yes, some of the things would be completely new. Please ignore. Some of the things which you have seen, right? Word count in Java world, just try to Google it out. You will find out there are at least 40 lines of program. By the way, this is the program of word count in Spark world. It is just one line. Just one line of this program. Okay, now let me just run this. Okay, you remember I was telling you about the lazy processing? So nothing has happened till now. It's all about, because I was just doing the data transformation. And by the way, those people who must be a bit curious, see this, all of this is RDD. Okay, anyway, let me just fire it. Quick. Done. Guys, see this. You're done. By the way, please look at the number of seconds. I just highlighted 0.741143 seconds. Saw that? Guys, saw that? Everybody? It's the same data, same machine, just that Spark versus Yarn. Right? It's not like I'm just doing something here or there, right? It's the very same thing. Okay, same memory, same RAM, everything. So this is just one example, guys. There are various others, right? And this should be quite compelling case for you to understand that the same thing can be done much faster, and that's what is drawing a lot of attention for businesses. I hope, guys, you just enjoyed this small little presentation and this demo, this session as well. Thanks a lot. I have actually gone overboard with 10 more minutes, and I hope you liked it. And if you just liked it, then I would definitely love to see ideally all, or at least some of you, in the coming batch, which is gonna start soon. Thanks a lot, guys, for your time. It was really encouraging. Just that, requesting a small thing, guys, do fill the feedback when you leave the webinar, please. That is really helpful. Thanks a lot, guys. With that, leaving now. Bye for now. See you in the classes.